Hello, kids, and welcome to our next installment of video lessons for Enriched Geometry. Going nuts, you guys. Okay, our next lesson is proving a quadrilateral is a parallelogram. So let's break this down. Remember, a quadrilateral is a four-sided polygon, and we have to use one of our properties that we learned of a parallelogram to show that that quadrilateral is indeed a parallelogram. So as long as your four-sided figure satisfies one of our properties of a parallelogram, then it is indeed a parallelogram. So just a quick recap here. These are our 6 properties. Key thing though, that I just want to drill into your head, it needs to be both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, and both pairs of opposite angles are congruent. It can't just be one, it has to be both, okay? And then just to keep going through our list, diagonals cut each other in half. Angles next to each other are supplementary, they add to 180. And this is that weird one. If your diagram shows one pair of sides is parallel and congruent, then it is indeed a parallelogram. So we're going to start off with some pretty just basic examples here. It says determine if the parallelogram is, let's back it up. Determine if the quadrilateral is a parallelogram. Justify your answer. So this is big. You can't just say yes or no. You got to give me a reason why. Otherwise, it's just going to be wrong. Don't be wrong because you're lazy. Just tell me why, okay? So if we look here, I have one pair of sides that are congruent, 5 and 5, and 12 and 12. So do you guys see how we have both pairs of sides that are congruent? So this would be a yes. It's a parallelogram because both pairs of opposite sides are congruent. And you can kind of abbreviate that however you want, but you got to give me something more than just yes or no. Okay? So this satisfied that both pairs of sides are congruent. Okay, let's look at our next example here. It's a really bad picture, but this is actually a tick mark and a tick mark. So I have one pair of sides that are congruent, but not both that we know of. And I have one pair of opposite angles that are congruent, but not both. So do you guys see how there's just not enough info? It definitely could be a parallelogram, but just based on what we are given, we don't know. So we're going to say, nope, not enough info. We don't know. Definitely could be, but based on what we're given, we can't say for certain. So in your homework, you'll see examples like this. Or you might have something on the coordinate grid. And when you have problems on the coordinate grid, we're going to use either the distance formula, slope, or midpoint to help us show that we have a parallelogram. So I know you guys have worked the distance formula a lot, but if you want to jot that down again to have it in your notes, there it is. This would be helpful when we are trying to show that opposite sides are congruent because this would show us equal lengths. So I'm probably just going to put that in that little box. Shows opposite sides are congruent. So that's why you would use the distance formula. It would help you show that opposite sides are congruent. What would slope help us show? So think of your properties. Which property would it help us show? Well, it would help us show that sides are parallel, right? Because that's what slope is. It's telling you how steep a line is. So if we have the same steepness, we would know that our lines are parallel. So this would show sides are parallel. And then our last one here, midpoint. Why would you use a midpoint? So again, if you think of your properties, the only one that kind of makes sense would be that your diagonals bisect each other, right? And if you remember from our previous video lesson, they would share a midpoint. So this would show that your diagonals share a midpoint. Okay, so if I went through that quick, maybe pause the video so you can jot down this information. Make sure you have it down written correctly, especially your pluses and your minuses in all of our formulas. You don't want to write those down wrong. So let's see what this would potentially look like in a problem. All right, here we go. It says graph the quadrilateral QRST with vertices Q, R, S, and T. Determine if the quadrilateral is a parallelogram. So step one, let's graph it and see what we're working with here. So Q, -1, 3. Definitely label your points. It will make your life easier, I promise. Okay, so just kind of eyeballing it. I'm kind of getting parallelogram vibes. I don't know about you guys, but it kind of looks like one to me. So now, since it doesn't specify using the distance formula, using midpoint, using whatever, you can do whatever you want. For efficiency, the easiest thing to do, since it's on a grid, would be to show that your opposite sides are parallel, because remember guys, slope you just count. So it's pretty easy, right? So if we wanted to show our sides are parallel, we would just count our slope. So if I wanted to find the slope of QT, remember slope is rise over run. So I go up 1, 2, 3, 4 over 1. So my slope is 4 over 1, or just 4. Let's check to see RS has the same slope. 1, 2, 3, 4 over 1. So far, so good there. Now let's check to see if QR and TS are parallel. So if I look at QR, I'm going down 1, 2 over 1, 2, 3, 4. So -2 over 4 is really -1/2. If you reduce, let's do TS. Down 1, 2 over 1, 2, 3, 4. Folks, looks pretty good to me. Do we have both pairs of opposite sides that are parallel? Yep. So this would indeed be a parallelogram. So we're going to say yes. Both pairs of opposite sides are parallel. Okay, and as always, we got to throw in a little bit of algebra just to make sure we are working on those skills and don't forget about it because it is important. So these ones say find the value of the variable so that each quadrilateral is a parallelogram. So if we look on this first example, we have an X and a Y. Let's just do alphabetical order. Is that okay with you guys? So let's start with X. What do you guys know about opposite angles? They are equal. So we can write 7x equals 56. Divide by 7, x equals 8. Pretty straightforward, right? Similar thing here. Opposite angles are equal, so set those expressions equal to each other. Get your y's to one side, your numbers to the other. Y should equal 30. And our last one here, we know that opposite sides are equal. So again, let's just start with x. So we're going to have, 5x minus 2 equals 3x plus 4. Again, get your variables to one side, your numbers to the other, divide out. Hopefully you got x equals 3. And then our last one here, again, set our y expressions equal to each other because opposite sides are congruent. Divide out, and hopefully you get y equals 7. Woohoo! Okay, folks, that concludes our video lesson for today. As always, thank you for doing your part and watching this. It makes class go a lot smoother when you at least have an idea of what we're doing. And until then, enjoy the rest of your day, and I will see you soon.